A prism is the three-dimensional figure that you get when you take a one-dimensional figure, or a two-dimensional rather, and you extrude it along the third dimension. So if I was to take this hexagon and extrude it straight out in this direction, you can see I end up with a hexagon up here as well. We talk about the process of extrusion. If you have a sheet of, I don't know, sheet of metal, and you take pasta and or dough or something like that, and you push it through that shape, then everywhere along here, there you have that same cross-sectional shape. In this case, we have a hexagon, and that end we have a hexagon, and anywhere along the way, we would have a hexagon as well. In any case, we describe that as an extrusion. You don't really need to know that for this class, but this is where you typically see prisms when you're talking about extrusions. And extrusions are incredibly common when you're talking about manufacturing things because they're pretty easy to do. So, in any case, prisms are what we get when we extrude like that. Now, as far as vocabulary here, when we're talking about the various parts of this prism, we have what are called the lateral faces. When you hear the word lateral, you should think side, just like with two-dimensional figures. And the faces are the individual two-dimensional surfaces. So this would actually be a face of this prism. This one right here is a face as well. Now, if I wanted to be more specific with my descriptions, I can talk about the lateral faces. These are the faces that are on the side of the prism. And then I have these faces we would generally describe as the bases. That one and this one down here would be the two bases. Again, more vocabulary here. Vertices, each individual corner here, these are all vertices. The singular here is a vertex. We call those vertices, or an individual vertex. And then these lines that connect the vertices we call edges. So this is pretty constant terminology we use when we're describing things in geometry. We have vertices, edges, faces. We can talk about specific types of faces, like I said, lateral faces or bases. Those are the individual faces. All right, so I guess I already talked about faces here. Sides, edges. Okay, so we have in a right prism. A right prism is what we get when, if you can envision this extrusion, you're pushing something through the hole. If the cross-sectional areas are kind of at a perpendicular to the direction of the extrusion, then we end up with a right prism. But that doesn't always have to be. You can end up with something that's not a right prism. These ones right here kind of show it the cross-sectional this cross-sectional figure. The bases really, the top and the bottom bases. These are not at a right angle to the direction of the extrusion or the direction of these other these edges. And so that would be not a right prism. For the purposes of this class, we're going to be focusing on right prisms because things are easier to do here. So that's what we're going to be working with here. When you're looking at, just to kind of verify that the naming here is correct, if we can count the number of faces on this particular three-dimensional figure. You can see there's a hexagon, or a pentagon rather. It's a five-sided polygon for the base and for the two bases. We have 1, 2, 3, 4, 5 lateral faces. So that means in total there'd be 1, 2, and then plus 5. There's 7 faces here. It's the 5 going around for the 5 lateral faces and the 2 bases. The number of vertices here, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. Remember, the vertices are the individual, the points. And the edges, well, there's 1, 2, 3, 4, 5. If you're ever counting something like this, I do recommend you're kind of strategic about how you count them. So you can see I did all the vertical lines here first. Then I'm going to count the edges on the top, on the top part here. So 5, 6, 7, 8, 9, 10, and then the ones on the bottom. 11, 12, 13, 14, 15. So I count up 15 edges.